So the next thing I want to talk about a little bit is that motor driver board. Here it is. It's from Adafruit, and here's a larger picture of it. It's the Adafruit DRV8833 DC/stepper motor driver breakout board. Yay for Adafruit. Here's how you hook it up and some of the things I learned as I read about it. First of all, to control the motors, some pins from the microbit, I'm going to use 13 and 14, are going to go to AN1 and AN2. The microbit can either send a 0 for the output pin being off, or a 1 if the output pin is on. And if they're different, the motor will turn one way. If they're both 0s or both 1s, the motor's off. And if I switch the order of whether there's a 0 on 13 and a 1 on 14, or a 0 on 14 and a 1 on 13, will change the direction. That'll send a signal to A out and either drive motor A in the forward or reverse direction. And then same thing for motor B. So pins 15 and 16 from the microbit are going to connect to BN1 and BN2. And then there's this pin in the middle called SLP. That's the sleep pin. It needs to be tied to either somewhere between 3 and 10 volts, which will just be the 3.3 volt power on the microbit. If that's at 3 volts, it enables this chip to be on, and if it's not, then nothing will work on this chip. I tied a ground on this chip to the ground on the microbit, and then from the battery pack, I put the power wires from the battery pack in to the block connector, which you see right here. And notice there's a little plus sign next to the block connector where the positive wire from the battery goes, and a little negative sign next to where the negative goes. You don't have to connect anything to the AS and the BS pin. That has to do with if you want to disable the current protection in the breakout board, and we don't want to do that. And this board is good for voltages between 3 volts and 10 volts, and you can apply the logic level pins to anywhere between 3 and 10 volts as well.